Hi, my name is Parvat, and I'll be introducing the Solduino project, its core architecture, and the live demo. The Solduino project consists of the four modules. First one is the core module, RPC module, wallet module, and the transaction module. Starting with the core module consists of the library constant, SDK initialization, and some version management. RPC client module includes all the necessary HTTP communication method that is used in the Solana ecosystem. The wallet module consists of classes which are responsible for key pair generation, import and export of the private key signing message. The transaction module is responsible for the serialization and the creating of the transaction. This is the GitHub repository for the Solidino project. I'll attach the link, and it is completely open source, and we can verify all the working and the utility in this repo. The core feature the core feature of this SDK is the wallet operation, RPC communication, and the transaction operations. The wallet operations are basically creating, importing, and the signing and verification. The RPC communication, this has all the necessary RPC method which is used in day-to-day activity like airdrop, sending a transaction over a network, getting network health, etc. The third one is the transaction operation. We can perform the transaction operation on ESP32 like building a transfer instruction, creating some custom instruction, or signing of any transactions. Let me give you a working examples and the setup. First, we will go through the setup and then I will show you the demo. Let me show you how to start a local test validator and connect that to the ESP32 module. For that, we are going to start a Solana test validator and we are going to bind it to the network card. This will basically start the Solana test validator in the local host. You can see the RPC endpoint. But since the ESP32 is external hardware, we need the IP address for this machine in order to act as a RPC client. For that, we are going to run a command and see where this 127.0.1 is attached to. And we can see that this is attached to my this particular IP address. Make sure the ESP32 and the laptop has a same common Wi-Fi connection. And then we can use this IP address as a RPC endpoint with the dedicated port. This is the first Solduino basic RPC demo. Let me give you a walkthrough of the code and then I will upload it to ESP32 and I will show you the output. First, it starts with including the necessary header file. One header file is our SDK. We have initialized the password for the Wi-Fi connection and the RPC endpoint. Then account address, which we will going to test. There is an initialization of our SDK and the RPC client. This is the setup code. This whole part is a setup code, and this is the main loop. For this demo, we are going to code in the setup loop. Here it is the initialization of the serial communication with the baud rate. Here we are printing the SDK information, and here we are initializing the SDK. If there will be any error, we will just return it with the same initialization field. After that, connect to Wi-Fi. If we go to connect to Wi-Fi, we can see that it start the Wi-Fi communication with the assigned ID and password. And if it's connected, it just prints successfully. And after that, we'll start the initialization of the RPC client. And once it's successful, we will run this test demo function. The test demo function is in three parts. First is the network information, the second one is the account information, and third one is the network status. Let me give you a walkthrough of the each functions. The first is the test network information, which includes some basic RPC call, including the get version. We are printing the version, get slot, and the same we get block height, get health, and the get latest block hash. For the account information, we simply do the get account information RPC client dot get account information. It will take the object which is of account info type, and it will print the necessary information like owner, lamport, executable or not, and the rent epoch. Similar way, we can also fetch the balance or the lamport information for that account. And the last is show network status. Basically, it will print the get slot and the version. Let me upload this to the Arduino IDE. This is my Arduino IDE. I have pasted the entire code as it is because the ID and password are the correct and the RPC endpoints are the correct. I have connected my ESP32 and I'll try to upload this. One second. Just wait for a second, it's compiling. It is uploading the code to ESP32. And once we open the serial monitor, the serial monitor is basically whatever happening inside the ESP32. It will just work as a console for that. I'm not sure what happened. You can see it basically prints the ID and did some calls. We can see the current slot, block height, and the latest block hash. This is the account info, native loader, true. Lamport balance is one lamport, network slot. This is the second demo of Solduino wallet. Here we will see the wallet generation and the import of the key pair. Let me give you a walkthrough of that. These are basic setup for our SDK. This one is the setup for the Arduino. We basically initialize our serial communication and start our SDK, which will run these two functions. This function is doing is we are initializing an object. We are initializing an object of class key pair. That object will have multiple methods. One is the generate, which will generate a public key pair. And the public key pair, we are initializing an array of characters which will basically hold the public key. And in that object, there is an other method, get public key address. Once we will pass that address, it will basically assign the public key to this address and we can see it. The second one is the importing of wallet. Here we are importing a private key to the wallet. How we are doing is we are using the same class and there is a method import from private key base 58 and that will basically import the private key and we can get the public key address as we have done that earlier. Let me upload this code to IDE and Arduino, and we can see that. Yes, this is uploading. The uploading is done. Let me just restart the board and we can see this. The generated key pair. This is the public address and the public address for the imported wallet. How we can verify this is by doing a simple airdrop. Solana airdrop one so to that address in the localhost, and we can verify that it gets success. This is the third demo and probably the most important demo. In this demo, we are going to execute a series of instructions. The first one is creating the wallet. The second one will be requesting an airdrop. And the third will be this creating and signing the transfer transaction. And finally, the submission of the transaction. Let me give you a walkthrough of the code. This includes some basic header files. These are the credentials for the Wi-Fi. This is our RPC endpoint. These are some constant and the initialization of our SDK and the RPC. This is a global buffer. Here is our setup, and this in this setup we are calling a transfer function. Let me give you a walkthrough of the transfer function. Transfer function. The transfer functions, the first part is the creation of the wallet. Here we are creating two wallets. One will be the sender and one will be the receiver. In this way, we are invoking a generate function, and as soon as we invoke, the key pair will have a public key with a public and private key. We are just logging that information for the showcase purpose. For the showcase purpose, here we are extracting the keys which are needed for the transaction. We will receive the sender public key, receiver public key, and the sender private key. The sender key is important. The sender's private key is important because this will sign the transaction. And the second part is we are just requesting the airdrop from the RPC client to the sender's address. Here we are checking for the balance. Here we are waiting for the transaction confirmation. This also same. We are requesting airdrop for the receiver. Here we are doing a simple balance check. We are fetching the balance from the network and we are simply logging them. Now comes the main important part. Here we are creating a transaction. We are initializing a transaction object of class transaction. We are adding the transfer instruction in that with the proper account information. We are fetching the recent block hash and setting this recent block hash to the transaction. After that, we are signing that transaction. We are encoding that transaction and then we are sending that transaction to the RPC network. And finally, we are waiting for the signature to get confirmed. Let me upload this code to Arduino and see it's working. The code is compiling. Let me open the CME. And the status has started. It has created the wallet, requested a airdrop, and waiting for airdrop to confirm. Requesting an airdrop for the receiver, and now it will wait for airdrop to confirm. Yes. Checking balance, the sender has 1 and the receiver has 0. We have received the block hash amount. We have received the latest block hash and the amount we want to transfer. The signature is transferred and here is the signature. We can confirm this using the Explorer. Yeah. You can see that 0.01 Lamport has transferred from this wallet to this wallet. Let me show you the address. These are same. So this one is the Solduino Core SDK and it is ready for the integration. Thank you.